Open your new page, write your learning objective number or your homework problem number. And remember, this is practice and problem solving. Video won't teach you how to do it won't teach you the basics of how this works, so you can go watch other videos on how condensed structures are read. But we're just going to practice it some. So we've got C6H5. That's something you'll find commonly in condensed structures that tells you you've got a benzene ring connected to something else. In this case, it's connected to CH2, all in parentheses 5. Now we know that a carbon, if it has 2 hydrogen, can only have 2 other bonds. So these must be in a line. CH2 in parentheses with a number after means all those go in a line. So I've got 1 there, 2, 3, 4, 5, and then a CH3 which comes on the end. All right, I've done the line angle formula because it's quicker and I can see all the parts. Now I'll write the complete structure. Doesn't matter where I put the double bonds as long as they alternate because they move around. I'll connect the next carbon, 1, 2, 3, 4, 5, and then a CH3 sixth. Take the time to put in all the hydrogen. You can see why organic chemists don't write these complete structures very often. It takes a lot of clicking or a lot of writing or a lot of typing. And just 1 hydrogen on each of these in the ring to get the H5 there. Let's go here. Condensed structure. Copy down the C's. A double bond to another C. One, 2, 3, 4, 5, 6. This has 1, 2, 3 bonds, and it needs an H. This is just one isomer that I might have drawn like this. But it could also be drawn like this, because double bonds can't rotate, but we can connect the molecule either way. This up here would be the cis isomer, and this would be the trans isomer. All right, let's do the next one. Some more practice. Here we've got a C connected to an H. H is always going to go on the outside. Can't ever have an H connecting a C to an O. We've got an O. It could, because O can form 2 bonds, it could go to this C here. We know it's got a bond to this one. This C only has 1 bond so far, and it's going to have another bond going this way. Let's look at this C. This C has 2 bonds here and 1 bond to the C on the farthest right. There's some different ways you could try to make this happen. But we're looking for 4 things bonded to this C. Here's 1, here's 2. We really need another one. There's that C there. So we're going to use that C and put this O off to the side. O really wants 2 bonds, and it can make them in that carbonyl to the C. So this CHO tells you you've got an aldehyde group. Then we go to the third C and fill in the rest of the hydrogen. So CHO is something you can learn to look for. You can see how confusing it can be. This O is not actually in the line. Let's check out this O. Our C here on the second one has 3 H's. That leaves only 1 spot for the O to bond and no spots for the next C. So this time the O is going to go in between. And we have an ether. Go ahead and look at your functional group sheet and find ether. And aldehyde, and see how different they are. Here we've got something again with O's in between C's. Our first C is straightforward. 3 H's, and then it has to go to the next C. Now we've got 2 O's and a C. These 2 O's are both bonded to this carbon here. So if I put an O there and an O there, that's 3 bonds. So in theory, I could consider going down to a C down here for the 4th bond, but then each of my oxygens would only have 1 bond, and we don't want that. Oxygens want 2 bonds, so we're going to give the second one to this O. This oxygen is going to get its 2nd bond by going over to this C. This C has 2 H's and a C bonded to it, so it only has room for 1 more bond. It can take a little bit of puzzling, but something written like this, CO2, is going to give a carbonyl with an O connected to something else. So this is an ester. If we had an H here connected to the O, it would be a carboxylic acid. Okay, let's go to this next one. We've got 2 O's. And we've got to somehow fit those 2 O's in between two ethyl groups. Ethyl because they have 2 carbons. Each O wants a double bond. This carbon already has 1, 2, 3. This carbon already has 1, 2, 3. So they only have enough for 1. Well, we can make that work if we connect the O's in this way. Now each O has 2 bonds. This is called a peroxide. Not one of the functional groups you need to learn, or that you, and it may not be on your quick reference sheet, but you can see how you can figure that out from the condensed structure and how a chemist could figure that out unambiguously, even though it doesn't show all the bonds.